Welcome to this video, which will show you how to add sine waves using Excel. The first thing you need to do is decide what you want on your x-axis in degrees. So I'm going from minus 180 degrees up to 360 degrees in increments of 22.5, which is half of 45 degrees, of course. And once you've got your degrees, Excel can only compute trig functions on angles that are in radians. So you need to convert your degrees to radians by typing equals radians, then open bracket, and then type the cell that has the angle in degrees, or click the cell, close bracket, and press enter. And then drag down in the bottom corner so that all of the degrees are converted into radians. So 360 is 2 pi there, and 180 is pi, so we know it's done it right. I'm going to do voltage 1 is 2 sine x, voltage 2 is 3 sine x, and then the total voltage will be the sum of the other two. So for V1, I'm going to type equals 2 and then the star for times. Then I'm going to type sine, like sin, open brackets, and then give the angle in radians that I'm taking the sine of, close brackets, press enter, and then drag down to get all the values with the sine function applied to them. And then V2 is 3 times the sine, open brackets, of the angle in radians on the x-axis, press enter, then drag the formula down so it performs the operation on all of the angles. Then Vt is C2 plus D2, so it's just the two cells added, and then drag that down. So that didn't take long, and we've got 2 sine waves, and we've got a voltage called Vt that's the sum of the two. And then you can select, say, degrees, and then select V1, click Insert, then Chart. Then smooth scatter is what I go for. And we can see that V1 goes from minus 180 degrees to 360 degrees like we told it to. The voltage has an amplitude of 2 because it's 2 times the sine. Now I'm going to do V1 plotted against radians. So it goes from minus pi up to 2 pi. You can change the range depending on how much of it you want to see. Now I'm going to grab the titles, the angle, and all 3 voltages, click Insert Chart, and then Smooth Scatter. And now all 3 of the sine waves are plotted. Put a title in Vt equals V1 plus V2, so we know what we've done. V1's in blue there, V2's in like a red colour, and V total is in a... So now I've copied the degrees and radians angle, and I've got some cells to put voltage 1's amplitude and voltage 1's phase, and V2's amplitude and V2's phase. I can choose what they are, and I can change them as well. So I'll put the phase in degrees, the phase difference for each voltage, which can be 0 if you want normal sine waves. And then I need to put the phase difference, if any, in radians, because Excel can only do trig on radians. So to convert V1's phase difference, if I've put a phase difference in, it could be 0, but I click on the cell K2 there, and I put equals radians, open brackets, J2, or I can click on the degrees cell itself. And then press enter. Do the same for V2, convert the degrees phase shift into radians. And like I said, you don't have to have a phase shift, it's just if you want to put one in, because we usually have to add sine waves where one of them has a phase shift. So V1 is going to be A sine omega t plus a phase shift, where A is the amplitude of V1, which is cell I2. And I've called the phase shift for V1 pH1 just to make it shorter. And then V2 equals the amplitude of voltage 2 times the sine of omega t plus the phase shift for voltage 2. Just tidy it up a little bit. And then the total voltage is V1 plus V2. That's the easy bit to do. So V1 is going to be the amplitude for voltage 1. So put equals I2 times the sine, open brackets, of the angle in radians, omega t, plus the phase shift for voltage 1 in radians. You have to use the radians value, otherwise it won't work. But I have to force it to always use cell K2. I need to force it to use cell I2 as well, but I'll show you what goes wrong if you don't do that. So press enter. And now for voltage 2, it's going to be amplitude 2, as in cell M2, times the sine of omega t, which is cell B2, plus voltage 2's phase difference, if there is any. But I need to force it to always look at that cell. Even in rows below, we need it to always look at the phase difference and amplitude on the second row, and you'll see why. So if I just continue these two formulas and drag them down by the little plus sign right to the bottom, that row is correct, I2 is correct, but I need to force it to always look at the amplitude in cell I2 by putting the dollar sign in front of it. And I haven't done that in column D, so V2 has loads of zeros in it, because there it's looking at amplitude in cell M2, but afterwards it looks in empty cells. So we need to use the dollar sign to force subsequent rows of our sine function to always look at the same cell for amplitude and phase difference. So here it's looking at the right cell, but now the formula is looking at an empty cell. So all we need to do is, once you've clicked, you can press F4, or you can manually type the dollar sign in front of the column and the dollar sign in front of the row, then press enter. Then when you drag it down, it forces the equation to always look at the second row for the values for angle and amplitude. Then VT is easy to do. You just put C2 plus D2. You click enter, drag down the formula so it performs it on all the other cells, and then I've sped this bit up. You can just decide what you want to graph, but then I'll show you why I bothered putting the amplitude and phase in single cells. So this is a graph against radians on the x-axis, and it has V1, V2 and the sum of the two all plotted on a smooth scatter graph. And make it a bit bigger. Stick a title in so people know what the graph's for. So VT is V1 plus V2, adding sine waves with various amplitudes and phases. And there V1 has an amplitude of 2, because we told it to be 2. If we change it to 4, all the equations are recalculated and the graph is drawn again. So now V1's at 4 volts amplitude, has a phase shift of 30 degrees, and we can change it on the fly to have no phase shift for V1, and we can change the phase and the amplitude of V1 and V2, and the graph always shows all three on the same axis, and we don't need to perform any other formulas or anything. It's already done. As we change these values on the second row, because we forced them to be used with the dollar sign, the graphs always come out right. So this means you can change the graphs you're doing. I've put the amplitude and degrees in green, which tells me I can change them, and I've put the radians in red, and that tells me not to touch them, because the radians depends on what we put in for degrees. So I hope this was useful. Have a go yourselves, and good luck adding sine waves with different amplitudes and phases.